Okay, students, in this video, we're gonna continue working with the crankshaft. So by now, you should have probably submitted a homework with this component. What I want to do today is actually go step by step on how to solve that homework in case you might still have any questions. So as I mentioned, I left some hints at the end of this document for you to sort of take a look at, and they should really help you out trying to solve this component. So in this case, I give you three main sketches here. You should actually complete 5 total sketches. So we have what I call the main here in sort of pinkish color, and then we have one of the secondaries here in purple, and then we have one of the tabs here in green. Okay, and then of course you need 2 secondary sections and 2 tabs. So in this case, we're missing another secondary, which would just be the same sketch, except of being offset to the left, it would have to be offset to the right. And then the same thing for the tab, where we would need to have the tab essentially mirror about the y-axis. So the thick side would have to be on the left, and the thin side would have to be on the right. Okay, and then once you have all of these sketches, then you need sort of the thicknesses for each of the extrusions, and at the end all it is just multiple extrusions where the next extrusion starts where the previous one ended, and then it's a specific thickness, and so on and so forth. Now a couple of other things to take from the images before we start is here, so everything's just extrusions, start where the previous one ended. Look at the last image for the order of tabs and secondaries. Now the last sentence here is pretty important. So it says the secondaries can only attach to the tabs on the thin side. Okay, so what I mean by that is, if we take a look at this sketch, if we wanted to do an extrusion of this secondary, then we would have to already have a tab that looks just like the one depicted here before we do that extrusion. Okay, so any of the 2 secondaries, either this one or the one on the right side, can only attach to a tab. So a secondary can never attach directly to a primary or main, and the tab has to be, the secondary can only attach to the tab on the thin side. Okay, so just sort of keep that in mind when we're working on this specific component. Now also, we take a look at this last picture, we can see that the order of the tabs and secondaries changes. Okay, so in this case, in this first section here, we can see that my first secondary is in the down position, and then my second secondary is in the up. So we would call this order down up. Next one over is opposite. So this next torque section changes order. Okay, so before it was down up, this one is now up down, and then the next one over is also up down, and then the last one is down up again. So the 2 in the center are essentially the same, and the 2 on the outside are the same, and of course either of the 2, there's a 180 degree difference between them. Okay, so if this is down up, then this is up down down up again. Okay, so just sort of keep that in mind when we're building this. Okay, so now I'm gonna actually jump into Fusion, and let's get started with this particular component. Okay, so what I'll do is I'll just sort of copy this on my other display. That way I can take a look at the dimensions a little bit easier. Okay, now in instructions, I let you know that you should have 5 different sketches, right? So here's my first sketch. Now I'm also going to make sure that my units are millimeters still. Everything's in millimeters for all of these components for the engine. So I'm good here. Now my first sketch is just gonna be the main, which is that circle that's centered at the origin, and both the main and the secondary sections have a 20 millimeter circle. So there it is, 20 millimeter is fully constrained, fully defined, because I have position X, position Y, and I have the size. Angle doesn't matter for circle. So there's my first sketch, okay? And as you can see, if I open up the menu for sketches, I'll see sketch 1 there. Now what I'll do is I hit finish the sketch. I'll go ahead and create a new one and select the same plane. Now my new sketch is also going to be a circle, except this circle now has to have an offset to the left or right, whichever one you pick to do first. Okay, but before I can do that, notice how I have I don't have my x-axis, right? So what I'm going to do here is I'm going to type L and X for construction, and I'm going to create an x-axis as a reference or construction line. Okay, so there I have it. Now I can use a coincident constraint to make that center of the circle touch that x-axis line. Okay, now once I have that, then I also only need to do a position X. So that was my position Y. Now my position X is going to be this difference, and that dimension or distance I'll just make it 10, which is exactly half of 20. That's the perfect offset that I need, and you can also take a look at that in the document, in the PDF. So I'll go ahead and finish that sketch, and then I'll repeat the same sketch. Instead of having the offset to the left, now I'll do the offset to the right. Okay, so same process. I'm going to create a construction line, as you can see there, construction, and then I'm going to make that circle. I'm going to touch that circle there. There's 20, and then I'm going to add that dimension of 10. So there's my first 3 sketches. Finish the sketch. Now for the next one, what I'll do is I'll just turn off all of them, and then I'll start my 4th sketch. Now for my 4th sketch, it's a combination of circles and lines. Okay, so I'll start off with my circle. So the first circle has to be centered. Now that circle actually has to be 40 millimeters. Okay, so this circle is going to make the heavy side or the thick side of my tab, and then I just need to build the smaller side of the tab. Okay, so it's going to be another circle. Well, let me do a construction line first for my X. There we go. And then I'm going to build my second circle, which has to be 23. Okay, and then the offset for that 23 has to be the same 10 that we had previously. Okay, and then you can sort of visualize that from the images on the PDF. Okay, so we have this so far. Now I could probably trim away some of the excess pieces now, but I'm not gonna do that just yet. What I'll do next is I'm gonna build a vertical line like so, and what I'm gonna do with that line is I'm gonna give it that distance of 5, which you can find in the PDF as well. Okay, so that distance of 5, and now I can trim away some of the excess lines and curves. Okay, so I can trim away some of these things like so, and then of course I can trim away some of the insides here. And now all we have to do is sort of round off this corner going to the outsides. Okay, now what I'll do here is I'll create 2 horizontal lines, one there and one there, and I'm actually going to make them tangent to my smaller circle like so. The reason for that is I want to convert this corner into a 90 degree before I do the fillet. Okay, So what I'll do here is I'll trim away this, and then of course I'll trim away sort of the inside pieces like so. Okay, and same thing on this other side. Now this is not a requirement, like if you completed the homework without doing this, you still would have gotten a pretty close result to the real one. So it wouldn't be too bad or too crazy, but this is just the best way to get this done. And then finally we have these corners, these 90-degree corners, or perpendicular. What I'm going to do is I'm going to select both of them, and then I'll just type in 3 millimeters for both. Okay, and that's going to round them off correctly. Okay, so this is one of the 2 tabs. Now again, notice how everything I created, I always made sure that it was fully constrained, fully defined, and at the end we left off with a sketch that's fully defined, fully constrained. Okay, so that's what we want to see. Again, I'm going to turn off this this sketch, and then I'm going to go add a new one, and it's essentially going to be the same starting point. So I'll start with the 40 millimeter dimension or diameter for my first circle. I'll create my construction line for my x-axis, and then I'll create my second circle of 23. Okay, and then this one here also has to have a distance in x from the origin of 10, like so. Okay, now that this is done, I'll go ahead and create my vertical line. Again, notice at this step everything's fully defined, fully constrained, so nothing's going to move. So you want to make sure that that step is always covered before you make some extra shape or component. Okay, and then here I'll make sure I give that distance to that line, which is 5. Again, I'm fully defining the line before I carry it forward. Right, now I'll go ahead and trim away some of the excess, as we can see here, and then the inside lines as well. And now just to show you, you could have done just fillets here, and they could be close but not quite. Okay, so if you just do fillets, I'll show you, I'm doing this to show you the difference, right? So as you can see here, this smaller circle doesn't quite end in a horizontal line and then goes to the curve. You actually have sort of this down angle down here, or radius. In this case, it might not be a huge difference, but in some designs, little details like this might just cause less material to be present, and it might be sort of sometimes like a concentration of stress or things like that. So again, just little things to look at. And again, you can see that here you'll only find the tangent constraint, but you're not really finding any of like the horizontals or anything like that. Whereas in my other sketch, so I'll finish that previous one first, and then if I go to this other sketch, here you find the tangent constraint, and then you have another tangent for this arc, and then you have this perpendicular, because that's perpendicular or horizontal, right? So again, just a very subtle difference, but sometimes small differences make a huge impact. Okay, so in this case, I'll go ahead and finish the sketch. You will see how I have 5 separate sketches, all of them present in the same plane. Okay, so it's the same one plane, just 5 different sketches, one on top of the other. Okay, now what we'll do with these sketches is we're gonna actually turn them on and off as we need them. The reason for that is we're gonna actually start creating the actual body or solid. Okay, so I'll turn all of them off except for the first sketch, or the main, and then this one I'll start off with an extrusion, and then that first extrusion is 25.5 millimeters. Okay, so this is going from 0 to 25.5. Okay, so there's my first extrusion. Now for my second extrusion, it would have to be a tab. Remember, secondaries can only attach to tabs. So in this case, if I wanted to do that secondary, that would be attaching to the main, so that cannot work. Okay, so it has to be a tab. It can either be this one or this one, doesn't really matter. Okay, so I'll pick this one, and then what I'll do is I'll do that first extrusion. But what I need to understand from this is anytime you start an extrusion, by default your starting point is always going to be the plane where you created the sketch or the profile. Okay, now this is all good if you understand what you're doing, but in this case I don't want this new extrusion to start in the original plane. I want this new extrusion to start from object, and then that object is gonna be where that previous extrusion ended. Okay, and then all I need to do is actually define this new thickness. Okay, so tabs always have to be 3 millimeters. So all you have to do is select the starting point where the previous one ended, give it the specific thickness that that particular component needs to be, and then carry forward. Okay, so in this case, this is my second sketch or second extrusion down from my first tab. Okay, now what I'll do is I'll select the new sketch that needs to be extruded. So if this is a tab, then I now need a secondary. Okay, so that secondary can either be the one in this case towards the right, or it can be the secondary towards the left. Okay, again, if you look at the hints, secondaries can only attach to the tabs on the thin side. So this wouldn't work because this secondary is trying to attach to the thick side. Okay, so it has to be the other secondary. Okay, so in this case I'll select that as my extrusion from object, from my start point, select that last surface, and then the thickness for the secondary has to be 4 millimeters. Hit enter. Okay, now this secondary can only attach to a tab. So again, this secondary can only attach to a tab on the thin side. So does it have to be this tab, or does it have to be this tab? Okay, so again, the thin side, this is towards the left, but my secondary is on the right, so it has to be the other one. There we go. Extrude it, select from object as my starting point, and then the tab itself has to be 3 millimeter thickness. Okay, now between each of the tab sections, and let me pull that up here, between each of the tab sections, so right now we created A, we created the first set of B, and then we created the first C. Now D here, that's a main as well. Okay, it's another super small section of main that's only 2 millimeters thick. Okay, so what I'll do is again, let me jump to Fusion. I need a little piece of main, so again I'll start off the main, and then what I'll do is I'll extrude it, my start point from object, and then the thickness has to be 2 millimeters. So that one's the thinnest of all of the sections, and then just carry on. So now I need the opposite tab, and then the thickness is 3, and then I need the other secondary, so on the left, that's good, thickness of 4, and then the same tab as this previous one, so this one, thickness of 3 again. Okay, so we are done with the first torque section. Okay, now we just need to repeat the process over and over and over until we're essentially done. Now I'll show you the next one, and then I'll stop the video for a second and then finish it off camera, and then finish off the video. Okay, so here what I'll do is, again, it's another piece of main from object. Now again, this has to be 25.5, and then here we have to be careful. So remember the order, where the order changes. So we have down up, the next one over has to be up down. So this one and this one, they sort of are the same, right? Like the two on the ends. So the final one on the first and the first one on the second, they're the same. Okay, so again, what I'll do is I'll just make sure I carry this tab first. Okay, so there it is, that's that tab. And then from object, that last one, thickness of 3, and then the only secondary that can attach to that one is this one, thickness of 4, and then it's the same tab, again thickness of 3, and then it's a main, just 2, and then it's the other tab now, so the opposite to this one that we have. You see, I messed up already. So again, it's this one, extrude from object, there we go, thickness of 3, and then it's that secondary, thickness of 4, and then it's the same tab, thickness of 3. Okay, and this is sort of what it's looking like right now. Okay, so we have main tab, secondary tab, main tab, secondary tab, main tab, secondary. So it's almost like a rhythm. Okay, you're always gonna have that same order. So main tab, secondary tab, main tab, secondary tab, main tab, secondary tab, main tab, secondary tab, all over. So really the decision making only takes place when which tab to select next. Okay, so just sort of be careful with that a little bit. And then what I'll do here is I'll stop the video for a second, I'll finish off the rest, and then I'll give you some final comments. Okay, so so right here I'm just finishing off the last few extrusions. Now in these sections you have to be really careful, because if you do mess up one of the extrusions here, then that can give you a very hard time once we're trying to assemble the whole thing. So you really have to make sure that all of your extrusions here make sense and that they're all correct, and then you should be able to assemble the whole engine without any issues. So again, take your time when doing this stuff. If you don't quite understand everything that's going on, I suggest you stop the video, rewind it, take a look at it as many times as you need, so you can really understand what's going on, and you don't make any mistakes. Okay, and then finally, this is what we're left with. So again, really nothing crazy complicated. I mean, the component itself is pretty complex, but it shouldn't be something completely crazy to do or really hard to do. The sketches, all they are is a couple of circles, a couple of lines, maybe a fillet here and there, but other than that, the rest is just extrusions. Okay, so as long as you understand how to do extrude, you should be able to create complex components like this. Okay, now a little bit of background as to why crankshafts look like this. Now, this is not what an actual crankshaft looks like in real life. This is sort of a hybrid type of component. The reason for this is I'm actually accounting for a 3D printing method for this, all of these components. So in an effort to try to save as much space, because I am very limited as far as the printing envelope or the printing area that I have, I try to make all of these components as small as possible, but while still being functional. Okay, so this is the reason why I made the crankshaft look like this. Okay, now we do have these offsets. So one of them is up, down, down, up, down, up, down. We're going to take care of that offset within the pistons themselves. If you recall, the piston head only has, so let me find that piston head. So the piston head has that offset, right? So both tabs are not centered. The reason for that is the offset has to be to one side. And then you'll really see why as soon as we start assembling all of these components together. So just sort of keep that in mind. Now, again, it's very, very, very important that you take care of all of the right measurements for these components, especially the crankshaft. If you mess something up, which you can mess up something very easily, then chances are once you mess something like that up, then something else is not going to fit correctly, and then you start talking about tolerances and things like that. So just sort of be careful with that, okay? And then here, again, the background behind crankshafts, why they have the tabs looking like that. If you think about it, when you're adding the secondaries, you're actually creating weight that's offset, so it's distance from the center axis, right? So anytime you have a mass outside of the center of rotation, then you're just gonna start dealing with things like a momentum and centrifugal forces and things like that. So this extra weight most of the time will mean that you're, in this case, the shaft will try to start sort of bending and buckling and doing crazy stuff. So in order for engineers to mitigate those things from happening, what they do is they just balance out the extra weight of the secondaries by adding extra weight on the opposite side. Okay, so that way both weights counteract and you sort of have a balance within the material. Okay, so again, the tabs are there in place to sort of counteract the extra weight of the secondary, and of course the reason of the secondary is to have the offset. That offset is ultimately going to define how far up and down your pistons move. So the bigger the offset on the secondary, then the bigger travel you're going to have on the piston. Okay, and again, there's a lot more engineering going into those components, but in this case we're just sort of taking a look at the very simple example, so just keep that in mind. Okay, we can always go back and modify the crankshaft, do a smaller offset or do a bigger offset, and then we can always see how that affects the piston travel. Okay, so we'll go ahead and stop the video here. If you have any questions on any of this material, you can always shoot me an email. Again, you have all the information you should need. If you still are having trouble, I suggest you review this video as many times as you need. The actual component is not crazy complicated. It might just take a little bit of time to actually understand what's going on. Okay, so I'll see you in the next video.